All right, this lesson you are learning about proportions, what a proportion is. You've already dealt with this a little bit. We just didn't call it a proportion. When you see 2 over 3 equals 4 over 6, we have called these what? Equivalent fractions. So all a proportion is an equivalent fraction. You're stating that two ratios are equivalent. You can also say the phrase two quantities that form a proportion are equivalent. So bottom line, if I were to reduce both of these, they're going to end up being the same fraction. In this case, it would be 2/3. Okay? So all you're going to be doing this lesson is telling me whether ratios or proportions are equivalent. Because it can't be a proportion if it's not equivalent. Make sense? Mm-hmm. All right. So put this in your journals. Example 1. Tell whether the ratios form a proportion. So we have 4/10 and 10/25. Okay, so looking at it quickly, can you tell whether this is going to be, if they're going to be equivalent?
They're not going to be equivalent because 4 can't go.
We'll see. So what we need to do is reduce both of these. What can reduce 4/10 to? Divide both by 2, we get 2 over 5. What can we divide the 10 and 25 by?
5.
10 divided by 5 is? And 25 divided by 5 is?
5. I guess not.
That's okay. So you see, sometimes when you first glance at it, it doesn't look like it could be a proportion, but in this case it was. So you would say, yes, they form a proportion. It's a hard word for me to say sometimes. Proportion.
Was that the worst example?
That was just number 1A. Okay, now let's do B. So we have 6 over 4 and 8 over 12. Let's reduce both of these. 6 over 4, what can we divide that by? 2. Divide both by 2. We get 3 over 2. What can we divide 8 and 12 by?
4.
4. Divide by 4. And we get 2 over 3. 2 over 3. Are these two ratios proportional?
No.
No, they're reciprocals, aren't they? 3 over 2, reciprocal is flipped. So 3 over 2 is 2 over 3. So this would be not proportional. Make sense? All right, grab your paper. Let's do some of these. Number 1. We have 1/2 and 5/10. Can I reduce 1/2?
Yeah, no.
No, it's already reduced. Reduce 5/10. So we'll divide both by
5.
Which would be 5 divided by 5 is
1.
And 10 divided by 5 is
2.
So are these proportional?
Yep.
Absolutely. Make sure you show your work. It's not a whole lot to write, so shouldn't be too bad. All right, we have 4/6 and 18 over 24. What can I divide into 4/6?
4. 2.
Divide by 2, which would be 2 over 3. What can I divide into 18 and 24?
6.
Divide by 6 is a nice big number. 18 divided by 6 is
3.
And 24 divided by 6 is
4.
Can't reduce that anymore. Are these proportional?
No.
So you're going to say not proportional.
Wait, they have to be the same number?
Yes, they have to reduce to the same thing. That's how you know whether they're equivalent or not. Good? All right, let's do number 3. We have 10 over 3 and 5 over 6. 5 over 6, can that be reduced?
No.
It's already reduced. 10 over 3, can that be reduced?
mean, you could put it into a big whole
It'd be a decimal. So that's already there. You can't reduce either one of those. So are they proportional?
No.
No. You could have been putting yes, no, sorry.
Really?
Yeah. You can just do it for the last two. Number 4, we have 25 over 20 and 15 over 12. What can I divide into 25 over 20? 5. So that'd be 5 on top and what on bottom?
4.
4. What can I divide into 15 over 12?
3.
3. So you'd get 5 on top and 4 on the bottom. Are they proportional?
Yes.
So you can write yes. Sorry about that. Hey, you got used to spelling proportional. Good practice.
That's it.
Important thing. You guys are going to like this lesson. It's not a hard one.
I know.
Good? All right, let's look at our next key idea. You should have already written this in your journal, but if you haven't, you better start scribbling. Okay, we're going to talk about cross products. Whoa. In the proportion A over B equals C over D, the products A and D and B and C are called cross products. That makes sense, guys. You've heard cross multiply and divide, right? I've said that multiple times. Cross products are the numbers opposite top and bottom and across from each other. Cross products of a proportion are always equal. Let me say that again. Cross products of a proportion are always equal.
How would it be equal?
So if I say, what's 2 times 6?
12.
And what's 3 times 4?
4. 12.
Does 12 equal 12? So now we have a faster way to solve to see if it's proportional. Because we're just going to cross product. This is, if you notice, the first step to a butterfly, which is what we use to find out which fraction is larger or smaller.
Will it always be equal for cross product?
Yes. Cross products of a proportion are equal.
Is it certain or any fraction?
What do you mean?
For cross products, just any fraction?
Any two fractions, you can do the cross products and it'll tell you whether that fraction is equal to the other fraction. All right, so practice this on example 2. Put this in your journals. All right, we have a real life word problem. You swim your first 4 laps in 2.4 minutes. You complete 16 laps in 12 minutes. Is the number of laps proportional to your time? Okay, so there's 2 different methods you could do. I could do the first method where I say how we swam 2.4 minutes in 4 laps and 12 minutes in 16 laps, right? My first method is to reduce both of those to see if they equal. The second method is to multiply cross products. So let's just do that one. So I would do 2.4 times 16, which would give you what? Yeah, who's going to win the calculator race? I think Abraham's going to win.
16, right?
Yep.
It's 38.4.
38.4. And then the second one was 12 times 4.
48.
Are these two numbers equal?
No.
So then these two ratios or proportions, they're not a proportional. Not a proportion. I told you I'm having troubles with that word.
In the book, they have like...
Yeah. Yes, when you see it say 38.4, we're trying to find out if they're equal. Obviously they're not, so you put a slash that says this means not equal. It's another way you could write that. Either way. I don't care. Either way you want. All right, last one, number 5 on your papers. you read the first 20 pages of a book in 25 minutes. So 20 pages for 25 minutes. So I made my first ratio. We're trying to find out if it's a proportion. You read the next 36, and if you need to, guys, label these so because you have to put this, yeah, number 5 on your own. I would label it because you have to make sure you put, like in this case, pages over minutes. If I accidentally on my second proportion wrote minutes over pages, it wouldn't work out. Okay, the second time you read 36 pages in 45 minutes. So I'm going to say 36 pages on top over 45 minutes. Okay, so shall we use the cross products method?
Yeah. But you multiply the bottom to the top.
So 20 times 45, and then we'll do 25 times 36. So 20 times 36 is, oh, not 36.
45 is 900.
900. Okay, and then somebody do 25 times 36. Do it.
900.
John, what'd you get?
I did do it.
I got 900.
So it's a proportional?
Yeah, so does 900 equal 900?
Yes.
Yes, so you would say yes. That means he read about the same number of pages per minute the whole time. Okay, there's the on your own finished. You do, let's see, this is OYO 1 through 5. You can turn that in or you can add to it the exercises, whichever you prefer. You're doing 5 through 27.